Earlier today, I was asked about question number 9 from the challenge set 24 about inverse functions, and I just wanted to make a little video to check in with you guys and make sure you understand a few important ideas about inverse functions. So, first of all, notice my problem journal entry has a title and a date, and I'm also clearly indicating the problem I'm working on, and I took the time to copy the text of the problem here just so that I don't have to, anyone who's reading this or looking at this video doesn't have to go referencing the actual challenge set to know what it is that we're trying to do here. And I'm just going to start by reading. It says, for each function, find the inverse of f of x, sketch y equals f of x, y equals the inverse of f of x, and y equals x on the same axes. And so what we're doing here, and again, I'll just remind you, this is notation right here. This little negative one side is not really, it's not really an exponent. Instead, it's just to indicate that this little expression here, we say this is the inverse of f of x. And remember, if you have a function like the one they gave us here, f of x, we take a value and we put it in for x, like 7 or 3 or something. And that's like the input. And then we do this, we evaluate this expression over here, and that gives us the output. And what an inverse function does is it takes that output and it maps back to the input that produced it. And so the first thing we're going to do algebraically over here is we're going to find the inverse of f of x, given that this is the definition here of f of x. And the first thing I do is I just substitute y for my output. So now I've got an input and an output in equation form, and this is a very familiar form to us, of course. And then I switch the x and the y. And what I'm doing is I'm making the input the output and the output the input. And then I solve this equation right here for y. I get the y by itself by first adding 5, subtracting 5 from both sides and then dividing both sides by 2. And then I just write it in this more familiar left to right direction. And then finally I go back to my function, in this case inverse function definition, and I can say that the inverse of f of x is, and I rewrote this in slope-intercept form because I know that I'm going to have to graph it. But just, it's worth noting, the original function takes a value, multiplies it by 2, and then adds 5. And what our inverse function does is it takes a value, subtracts 5, and then divides by 2. And you could maybe compare what's happening in this formula to what's happening in this one and see that they are in fact inverses. And when we graph them, we get some other information that shows us that they're inverses. So I drew a set of axes over here. This right here, this line is my f of x, okay? Y-intercept of 5, slope of positive 2. And then this dotted line right here is the line, let me label it, y equals x. And that's a really important line because of this right here. When you switch the x and the y, it definitely changes the relationship unless x and y are equal to one another, and then the relationship is the same, whichever value you put in whichever of these two places. And that's why this line is interesting. And then when I graph the inverse function, I have a y-intercept of negative 5 halves and a slope of 1 half. And you'll notice that this line, the inverse function, is a reflection of the function, the original function, over the line y equals x. So in other words, and we can just kind of do a couple of points here. Look at this. This is the point 0, 5 on the original function f of x. And if you switch the y and the x values, you get 5, 0. And that's a point on the inverse function. So that's pretty interesting. And it has everything to do with the fact that we switched the inputs and outputs in order to get to the inverse function. I hope that clarifies a few things about how to find the actual formula or equation for an inverse function. And then also what happens on the graph that is maybe interesting. is that the inverse of a function is the reflection of the original function over the line y equals x. Now, this is a linear function, which is pretty simple, but we will find this pattern again and again as we explore inverse functions.